Okay, so we need to solve this system of equations using Cramer's rule. So the very first thing that we need to do is we need to define matrix A. Matrix A is going to be our matrix of coefficients. So all I have to do is look at the coefficients in the system, and they're going to be in the matrix. So for example, the first equation have the coefficients of -1, -2, and 4. So that's going to be my first row for my matrix, and likewise for the second row and the third row. Now with Cramer's rule, there's three formulas I need to know. These formulas help me find x, y, and z. More or less they are x, y, and z. So each formula is really nothing more than a fraction. In the denominator of each fraction is the determinant of a, which is nice. The numerator is the determinant of a new matrix. It's going to be modified from your coefficient matrix. So this matrix really is made up of characters A, B, C, D, E, F, G, H, I. All of these letters can be assigned to all your different coefficients. So for example, E, that's really 1. These guys over here, these are J, K, and L. These are solutions. In your new matrices in your denominators, you're going to modify this matrix. So for here, I'm solving for x. I'm not touching my y column, I'm not touching my z column. So I'm going to have my y column, and I'm going to have my z column. However, since I'm solving for x, the coefficients for x are going to be replaced with j, k, and l. Likewise, for this y equation, my first column and my last column are untouched. But since I'm solving for the y's, I'm going to replace them with j, k, and l, and on to z, where my first two columns remain untouched, and I replace my z column with j, k, and l. So that's just it. I don't have to memorize anything as long as I understand that this coefficient matrix is my numerator, except I'm just taking out the column for the variable I'm solving for and replacing it with j, k, and l. So now I can do some calculations. I can find the determinant of a. So I write out my matrix. Now I'm ready to solve. When I solve for the determinant, remember to replicate my very first two columns. And what I'm going to do is I'm going to multiply starting from the upper left to the bottom right. So -1 times 1 times -3 is +3. I add that to the product of -2 times 2 times 2, which is -8. And I add that to the product of 4 times 1 times 1, which is 4. And I subtract the sum of the products going from the bottom left to the upper right. So I have 2, 1, 4, gives me 8. 1 times 2 times -1 is -2. And -3 times 1 times -2 is 6. Alright, so I have 3 plus -8, which is -5, plus 4, and that gives me a -1. I'm going to subtract 8 minus 2, which is 6, plus 6 is 12. 1 minus 12, or -1 minus 12, gives me a -13. So that's going to be the denominator for each one of these problems. Now, what I can do is I can move on to my next determinant that I have to solve. So I can probably look at my numerator for my x in Cramer's rule. And I can solve that. So let's find it. So if I have my J, B, C, K, E, F, L, H, I, that's going to be equal to this matrix. Notice how I leave my last two columns the same, and for my J, K, and L, I replace it with, up here, my negative 28, negative 11, and 30. Negative 28, right? Yeah, okay. Negative 28, negative 11, and 30. Great. Again, I replicate my first two columns, and now I'm ready to go. So negative 28 times 1 times negative 3, that's going to give me a positive 84. And I'm going to add that to negative 2 times 2 times 3, which is going to give me a negative 12. Oh, sorry. Oh, I almost made a mistake there. It's negative 2 times 2 times 30. That's going to be a negative 120. 4 times negative 11 times 1, and that's going to be a negative 44. And I subtract the product of 3 times 1 times 4, which is 120, plus 1 times 2 times negative 28, negative 56, plus negative 3 times negative 11 times negative 2 gives me a negative 56. Alright, so I have 84 minus 120 minus 44, and it gives me a negative 80. And I subtract from that 120 minus 56 minus 66, which is a negative 2. This gives me a negative 78. Alright, next up to the plate is the numerator for my y variable. Alright, again, this column and my last column stay the same, and my middle column is replaced with the JKL. So I have negative 1, 1, 2, 4, 2, negative 3. And I replace that middle with negative 28, negative 11, and 30. And yet again, as I'm taking the determinant, I replicate my first two columns. So negative 11 times negative 1 times negative 3, and it's going to give me a negative 33. I'm going to add that to negative 28 times 2 times 2, or 112, and I believe that's a negative 112, plus 4 times 1 times 30, which is 120, minus 2 times negative 11 times 4, that's going to give me a negative 88, plus 30 times 2 times negative 1, and that's going to give me a negative 60, and a negative 3 times 1 times 28, that's going to give me a positive 84. Okay, so a little bit of math here. Negative 33 plus a negative 112 plus 120 gives me a negative 25, minus negative 88 minus 60 plus 84 gives me a negative 64. So I have a negative 25 plus 64, and that's going to give me 39. Okay. And last but certainly not least is my last matrix. Alright, so my first two columns stay the same. And I replace the last, my z column, with the j, k, and the l. So I have negative 1, 1, 2, negative 2, 1, 1, and negative 28, negative 11, and 30. Again, I replicate my first two columns, and I'm ready to solve. So negative 1 times 1 times 30, it's going to give me a negative 30. And that's to negative 2 times negative 11 times 2. That's going to give me a positive 44. Plus negative 28 times 1 is negative 28. I'm going to subtract 2 times 1 times negative 28, and that's going to give me a negative 56. Plus 1 times negative 11 times negative 1 is 11. Plus negative, or 30 times 1 times negative 2, which is a negative 60. Okay, so now I can add. So I have negative 30 plus 44 minus 28 equals a negative 14 minus negative 56 plus 11 plus a negative 60. It's negative 105. So I have negative 14 minus a negative 105. That's just going to give me good old positive 91. I have 78, 39, and 91. These are going to be the numerators for my fraction. So for example, my first value here, x, in my numerator, I'm going to have negative 78. In my denominator, I have my negative 13. Well, 78 divided by 13 is 6. Negative divided by negative is positive, so I get positive 6. Y is going to be 39 over my negative 13. That's going to give me a negative 3. And then for z, in my numerator, we got a 91. In my denominator, we got a negative 13. And that's going to give me a negative 7. So my final solution is 6, negative 3, negative 7. So, it took us a little while to do, only because I was going through and explaining. When you're doing your tests, you should be explained to anybody, so you should be okay. And make sure you go back and you check these. So you plug these into any of your equations. So for example, this second equation, 6 plus negative 3, that's a positive 6, minus 14, I'm sorry, that's a negative, it's a positive 3, minus 14 gives me a negative 11. Check. So, good luck, and if you have any questions, send me an email.